Hello aspirants, I welcome you all on the YouTube channel of Analyst IAS. Our today's topic for topic Decodified is the Aditya-L1 mission. We will see why in news, what is Aditya-L1 mission, what are the Lagrangian points, then we will see internal structure of the sun. After that we will see the significance or importance of this mission. Then we will see some other solar missions which have been launched by NASA and others. Then we will come to our today's prelims practice question and the mains practice question. We'll start with the news, that why in news. So recently the ISRO chairman S. Somnath, speaking at the handover ceremony of the visible line emission coronagraph payload, said that the Aditya-L1 mission will be launched by June or July, as the launch window for the mission would close by August. Aditya-L1 is the first Indian space mission to observe the sun and the solar corona. So what is Aditya-L1 mission? Aditya-L1 mission is the first space-based Indian mission to study the sun from the Lagrangian point 1. I'll tell you what are Lagrangian points later, of the sun-earth system, which is roughly 1.5 million kilometers from the earth. The project was initially proposed as the Aditya-1, a 400 kg class satellite carrying a single payload, the visible emission line coronagraph. It was however renamed Aditya-L1 mission since the satellite was positioned in the hallowed orbit of the sun-earth system Lagrangian point 1, named after one of the many Sanskrit names of the sun, which is Aditya. Aditya is another name for the sun. Is scheduled to be launched from Sriharikota, Andhra Pradesh, using the Polar Satellite Launch Vehicle. So this was all about the mission. The space-based observatory will have 7 payloads on the board to study the sun's corona, solar emissions, solar winds and flares, and coronal masses ejections, and will carry out round the clock imaging of the sun. Now what are the major payloads of this? In total, Aditya-L1 has 7 payloads, of which the primary payload is the visible emission line coronagraph. This is the first one, designed and fabricated by the Indian Institute of Astrophysics, Bangalore. The satellite carries additional 6 payloads, which are SUIT, the Solar Ultraviolet Imaging Telescope, then SPECS, Aditya Solar Wind Particle Experiment, then PAPA or PAPA, Plasma Analyzer Package for Aditya, then you have SOLEX, Solar Low Energy X-ray Spectrometer, then you have HEL1OS, High Energy L1 Orbiting X-ray Spectrometer, and then you have the 6th one, which is magnetometer with enhanced science scope and objectives, possibility by extensive remote and in situ observation of the sun. So this is all about the L1 satellite. Now here these are the Lagrangian points. This one is the L1. Remember that this is between the earth and the sun. Basically these points are the points where there is neutral gravitation. It means that the gravitation from the earth and the sun remains equal, so our object can just stay there. There are some more things about it which I want you to know, that other orbital sweet spots just beyond high earth orbit, these are sweet spots, are the Lagrange points. At the Lagrange points, the pull of the gravity from the earth cancels out the pull of gravity from the sun. Anything placed at these points will feel equally pulled towards the earth and the sun, and will revolve with the earth around the sun. Of the 5 Lagrange points in the earth-sun system, only the last 2, which are L4 and L5, they are stable. A satellite at other 3 points is like a ball which is balanced on a peak of a steep hill. Any slight disturbance will push the satellite out of the Lagrange point like a ball rolling down a hill. So these 3 points, L2, L1 and L3, they basically need constant adjustments to stay balanced and in place. So these are like a ball on a hilltop. So these need to be balanced very frequently. And here is the L1 point. Remember that it is between the earth and the sun. Now this is the internal structure of the sun. We will discuss in detail. Even though astronomers have never been able to observe the Earth's interior, they have managed to figure out its structure by studying the surface and the gases surrounding it. We now know that our star is made up of the following layers. So the innermost is the core. Solar energy is produced at the center of the sun where temperature reaches this much Fahrenheit, and you have the data, you can write it. It is in the core that nuclear fusion takes place, releasing enormous amounts of energy that makes the sun shine. After this, the energy will go to the radiative zone. So the energy from the core slowly rises in the radiative zone. It takes the energy about 1 million years to travel out of the radiative zone. So it takes about 1 million years from here to here. Then you have convection zone. The convection zone carries the energy to just beneath the sun's surface. After that, you have basically the chromosphere is a thin layer of gas above the photosphere. This one is the photosphere. This gas is above the photosphere. This white one is the chromosphere. The photosphere is the visible surface of the sun where the temperature is about 10,000 degree Fahrenheit. This is the part that gives off light. It takes 8 minutes from this light to reach the earth. Then you have the chromosphere, which is white. It is a thin layer of gas above the photosphere. Along with the corona, it forms the sun's atmosphere. And here is the corona. So the corona is a thick layer of gases above the chromosphere. It extends for millions of miles or kilometers around the sun. The corona is the outermost layer of our local star. Along with the chromosphere, it is only visible during a total solar eclipse when the sun's surface completely hidden behind the moon. So the corona and the chromosphere will form the atmosphere, and rest I have told you about the internal structure of the sun as well. Now, what is the significance of the mission? The payload data will help understand the effect of the sun on the earth and its surroundings as well, especially in studying the patterns and impacts of the solar flares. The scientific studies by the satellite will enhance our current understanding of the solar corona and also provide vital data for space weather studies. VELC will help to observe the corona continuously, and the data provided by it is expected to answer many outstanding problems in the field of the solar astronomy. No other solar coronagraph in space has the ability to image the solar corona. I already told you what corona is, as close to the solar disk as VELC, which can image it as close as 1.05 times the solar radius. It can also do imaging, spectroscopy and polarimetry at the same time, and can take observations at a very high resolution and many times a second. Then there are other solar missions. So there are NASA's Parker Solar Probe. Its aim is to trace how energy and heat move through the sun's corona and to study the source of the solar wind's acceleration. Then you have Helios 2 Solar Probe. It was a joint venture between NASA and Space Agency of erstwhile West Germany, went within 43 million kilometers of the sun surface in 1976. Now we will come to our today's prelims fitness question, that with reference to Lagrange points, consider the following. At Lagrange points, the gravitational pull of the two large masses precisely equals the centripetal force required for a small object to move with them. At these points, inner space can be used by spacecraft to reduce fuel consumption needed to remain in position. I hope you all can answer it. Try to answer it, try to pause the video and try to answer it in the comment section. Then I'll let you know in this video itself. Now, what is Aditya-L1 recently launched? What is the significance of choosing Lagrangian points? So this was about your mains question. Now we will come to our today's prelims practice question. I hope you all must have answered it. So the first option says that the gravitational pull of the two large masses precisely equals the centripetal force which is required for a small object to move with them. So the satellite will move with the earth as well, Lagrangian points. So this can be correct. Now these points in the space can also be used for spacecraft to reduce the fuel consumption, as there is no gravitational pull of either of the planets. So the answer should be C. This was all about the today's video and the topic. Stay tuned for the next one. Have a nice day.